Hello, class, and welcome to section 4.1, Solving Linear Inequalities. So just like what we saw with the linear equations that we solved, we have linear inequalities in a variable x. This has an inequality symbol between a linear expression, some mx plus b, and a constant. So this is solving inequalities is the process of finding the solution set that satisfies the inequality. And these will be written in interval notation. And just like with those linear expressions that we've seen, these inequalities are equivalent if the solution sets are the same again. So 5x minus 9 is greater than or equal to 19, 5x is greater than or equal to 28, and x is greater than or equal to 28 over 5. These are all equivalent because they have the same solution set, right? All we did was add 9 between the first and the second. To both sides, we got rid of this 9, got 28 on the right, and then divide by 5 to get from the second to the third. Well, of course, 5 does not go in evenly to 28, so I just left it as a fraction. So when we multiply or divide by a negative number, the inequality that we have is reversed, right? So the addition property of inequality is the same as the addition property for equalities. If a is less than b, then a plus c is less than b plus c. If a is less than b, then a minus c is less than b minus c. So adding or subtracting c gives us the same answer. It gives us the same inequality as long as it's on both sides of that inequality. Positive multiplication, if a is less than b and c is positive, and a times c is less than b times c. Same thing with division. If a is less than b and c is positive, then a divided by c is less than b divided by c. But if we have the negative, if a is less than b and c is negative, then a times c is greater than b times c. Likewise, if a is less than b and c is negative, then a divided by c is greater than b divided by c. So the same thing here with like 10 is less than 14. If I multiply both sides by, let's say, -1, let me actually write that not that way. I'll write it up here. Let's multiply both sides of this by -1, right? We have -10 and -14, but is -10 less than -14? No, it's greater than it. So we have to flip that inequality symbol, which is the whole point of what that showed. So just quickly, interval notation, if we have an inequality such as x is greater than 8, the interval notation that we have is that the smallest number this can be is a, and it goes off towards infinity. Since infinity is a concept, we have a parenthesis around that. And since a is not included with this, there's no or equal to, it's a parenthesis. The graph of that will look something like this, ran as a number line. We have our number a, and let me just use a different color to highlight what I'm referencing. We have an open circle at a, and we would shade to the right. For x is greater than or equal to a, we have the same thing as this. Smallest number is a. We go off towards infinity. We have a parenthesis around the infinity, but now because of that or equal to, we have a bracket around that a. So again, number one with a in the middle, this would be a closed circle at a and shading to the right. But x is less than a. The highest that this could get is a, and it goes down towards negative infinity. Again, parentheses around this. The graph for that looks like this. At A, we would have our open circle at A shading to the left. And likewise, x is less than or equal to A. This would be negative infinity to A again, but now with a bracket on the other side of A. So as a number line, we have A here, and we would have a closed circle here shaded to the left, which would then comprise of our interval notation. Let me know if you have any questions or concerns, and be on the lookout for part 2. Thank you.